Hey everyone, welcome to the AI show. I am Cassie Breviu, and thanks so much for joining us today. We have lots of fun things to talk about. This is actually our first live stream this year, so I'm honored to be the one to be bringing it to you today. We are going to be looking at some really cool demos today from Intel. We're going to be looking at the Optimum library and the OpenVINO execution provider in ONNX Runtime. Hey, Seth. Thanks for stopping in. Who else is here? Where are you from? I'm in Minnesota. It is cold here, as you would expect, and about to get much colder. We're about to get a cold front. It's going to get like below zero, which is the worst. But yeah, so, and then after Intel, after they show some really amazing demos about how to optimize BERT, some natural language processing stuff, then we're going to be looking at how we can deploy a model with ONNX Runtime on the Raspberry Pi, which I love playing with IoT. So I'm really excited to show you guys that project. Cool. Well, I think we will jump right in. Hey everyone, I am Cassie Breviu, and you are not going to want to miss this episode of the AI Show, where we are going to talk to Intel about the OpenVINO toolkit inside ONNX Runtime. Let's take a look. Thanks so much for joining me today. Why don't you guys tell me a little bit about yourself?
Hey, Cassie. My name is Devang. I'm currently a technical product manager at Intel, part of the OpenVINO team, and I'm currently managing the product OpenVINO execution provider for ONNX Runtime.
Awesome.
Hi, Casey. I'm Akhila. I'm working as a deep learning engineer at Intel, and I'm working on various framework integrations, and one of them is ONNX Runtime. And I'm currently working on workflows, which is like ML ops.
Awesome. I just did a talk on ML ops. I think it's such a cool topic, and there's so much exciting things happening in that space. But today we're going to be talking about execution providers. And if you don't know what those are, they are part of ONNX Runtime, which allows you to accelerate your models on different hardware. So it allows you to optimize and take advantage of those different capabilities in different compute platforms. This is important for application developers because it allows them to deploy their models on different hardware, whether it's cloud and edge, and still get the performance that they need. So examples of those would be like CUDA DirectML or OpenVINO, like we're going to be talking about today. So let's jump in. How can developers creating ONNX models accelerate inference with Intel hardware? Can you introduce us to the OpenVINO execution provider?
Sure, absolutely, Cassie. So in a nutshell, OpenVINO Toolkit does all the magic aimed at boosting the performance of your deep learning models using some of the most advanced optimization techniques, specifically optimized for Intel hardware. So now developers can actually leverage the power of OpenVINO Toolkit through ONNX Runtime to accelerate inferencing of ONNX models. So how exactly does OpenVINO execution provider actually work? So users continue to actually import the ONNX Runtime library after installing our package from PyPy. It's basically pip install ONNX Runtime-OpenVINO. But now with a simple modification to the inference session line of code, where they have to just set the provider's OpenVINO execution provider, they can utilize the power of OpenVINO while using the ONNX Runtime APIs. All it takes is really that simple modification to the line of code. A little bit of history behind this is that back in 2019, Intel and Microsoft actually joined hands to create this product, which delivers this better inferencing performance on the same hardware compared to generic acceleration on Intel compute devices.
That's super awesome. So I love to see how things work. Can you share a demo that shows us how this flow actually works with the execution provider of the OpenVINO one and how that kind of works with Intel hardware?
Sure, absolutely. Absolutely. So today I'll be showing a demo that showcases a popular deep learning model right now called YOLO V7. This demo, basically the sample involves presenting an image to ONNX Runtime, which then uses the OpenVINO execution provider to run inferencing on an Intel CPU. And you'll be able to see the accelerated performance for yourself. So walking through this demo right now, first of all, we start off with just downloading the Cocoa validation dataset. That's the Cocoa dataset. It's a very popular dataset that the YOLO model is trained on. We have the export capability where we take the PyTorch model, because YOLO v7 was actually trained in PyTorch. That PyTorch model we converted to ONNX format, right? So for sake of time, I will not be running this cells, but we've already run this in the past. But we have converted the PyTorch model to ONNX, and we provide an input image. We download this input image. The image that we are downloading right now is an image of a cat. So that will be the image which we'll be inferring on. Afterwards, we do the pip install ONNX Runtime-OpenVINO, which I just mentioned, right? Which we are trying to get access to the OpenVINO execution provider. So we install this package. After this, we import all the required libraries. As you can see over here, we continue to just import ONNX Runtime itself. So once we pip install ONNX Runtime-OpenVINO, there's no real specific different package that we have to import. It's still Runtime package, the library that we have to import. So we do all the imports for the required libraries. The next part for us is actually doing the pre-processing of the image. So this is basically allowing to resize this image to a shape which is expected by the model, right? So that's essentially doing all the reshaping and all that stuff so that we can do it. This is actually right now a helper function. So we're going to be using this helper function later on in this demo we'll be making a call to do the pre-processing. Afterwards, what we do is we have various different labels. So we're actually assigning like color values to those labels, right? So based on the label, the detection that we're doing, based on that, that will be the image of that box of the detection. So that's essentially the color for the labels, mapping those. Mm-hmm. And then we have functions to do the reading and pre-processing of the image. So this is where we actually read the image in, and then we actually perform the pre-processing on that image itself. Next is when we actually look at how we can set or create this inference session through ONNX Runtime, right? So this function, another helper function where we have two parameters. One is the model cat, which is like which will be pointing to our ONNX model, and then over here the second parameter is a device argument, which we can pass in. So if we pass in CPU underscore FP32, which is it's in all caps, it will run the inferencing with OpenVINO execution provider on the CPU. But if it's all lowercase CPU, then it'll run it with the native ONNX Runtime or MLAS CPU execution provider for this model. And if no arguments are passed in or no thing it'll pass in, then we'll just use the default CPU execution provider for inferencing. So after we have all these helper functions all set, we go to the last function, which is called the run inference function. And this essentially is kind of putting all the pieces together, which does all the tasks such as pre-processing the input image. It creates the appropriate ONNX Runtime session as per our device argument. It runs the inference along with NMS on the predictions that for the number of runs asked. And it adds the bounding boxes on the detected objects and saves a copy of the inferred image, right? So it's essentially calling all our helper functions in this function so that we can kind of paint that whole story together in this. So once this function is all complete and we have everything all set, then we can actually begin our inferencing, right? So over here, we are passing in, like I mentioned before, the ONNX model is what we're pointing to, and the input image, which is the image of a cat. And for right now, we're running the iterations. The number of iterations is about 100 iterations. We can set the params accordingly and actually run inference function to do the actual inference. And as you can see over here, after we do the inferencing, the cat is detected over here. So you can see the cat label, and the accuracy is given over here at 0.929. And the average inference time with CPU execution provider on this Intel CPU is about 67 milliseconds. And then we can start running inferencing using OpenVINO execution provider on the same Intel CPU. And we can see that the accuracy is the same, 0.929, and we're detecting the cat. But we can see that the average inference time in milliseconds, the latency has been decreased to 32 milliseconds, which is almost like a 2x performance boost. So yeah. So in a nutshell, this is kind of like the flow that it takes to run with OpenVINO Execution Provider. And you can see just like um, it's really simple to use, and really it's really easy to use, and you can just get that 2x performance boost for some of these popular deep learning models.
Yeah, and like a lot of the code that you showed is things you'd be writing anyways, like the adjustments that you had to make in order to actually use the execution provider for that hardware to get that performance increase was not really that much. Like that was a very small piece of the overall demo.
Exactly, right? So it's super easy. Like I say, right? It's just a simple modification of that line of code. All you have to do is just that pip installation of ONNX Runtime-OpenVINO. You continue to import that ONNX Runtime library, and then just set the provider's OpenVINO execution provider if you're using an Intel hardware, and that accelerated performance is waiting for you.
That's awesome.
Yeah.
So I'm sure people would love to see some insights into the architecture of how this works. Would you show us that?
Absolutely. So sure, I can give like a quick overview of the architecture. So how it works is that the ONNX model, which is coming into the ONNX Runtime application, gets converted into an in-memory graph representation and goes into what we call a graph partitioner or a get capability module. So this module actually queries all the backends that are available, and it asks which part of the graph it can support. So the providers that we have enabled have to reply and say that these are the subgraphs that we support, and we have to provide handles back to ONNX Runtime. When it's time for the subgraphs to be executed, ONNX Runtime will then send that back to execution provider, and it will do the inference and send the output back. So in a nutshell, that's kind of how it works under the hood.
Cool. That's super helpful to kind of understand how we're able to get that optimization, keep the accuracy, and not really have to do that much extra work. I mean,
Yeah.
that's so cool. So talking about getting better performance, obviously large models and transformer models are very popular right now. I think most people have heard of Hugging Face at this point. And if you haven't, you should go look it up because they have amazing APIs and they're just doing really cool stuff in the space. Can you show us how we could use this to further optimize a Hugging Face model using quantization?
Yes, absolutely. We have some amazing tools from Intel just for optimization. One of them is Neural Network Compression Framework. It provides a suite of advanced methods for training time model optimization techniques within the DL framework, such as PyTorch and TensorFlow. It supports methods like quantization array training, accuracy array training, and fine tuning and filter pruning. Among these methods, quantization array training is pretty popular, and we would want to talk about this more um, going forward. Yeah, not a lot of a code. With just few lines of code, we can leverage uh, quantization techniques during training. Let me explain in detail. So I'm sure many of them might have heard about Hugging Face Transformers library. Optimum is a library that provides optimization techniques to Hugging Face Transformers training pipeline. We have NNCF and OpenVINO added to the Optimum library, which is called as Optimum Intel. Um, if the user has access to Hugging Face training pipeline with just few lines of code, they can enable quantization array training technique. So here is a code snippet. So if you have a existing training pipeline, you can just import ovconfig. Ovconfig has all the details about what is the size and what is the technique that you are trying to use, quantization array training. And this is a second import statement, question answering OV trainer instead of the default trainer. And you initialize it and you call the trainer. So the output of the training would be an optimized int8 PyTorch model. Using the optimized int8 model, we can run the inference for better performance.
So that's super great. Akhila, I believe you've done some work to showcase how users can quantize Hugging Face models and run inferencing with the OpenVINO execution provider for ONNX Runtime through a low-code workflow. Can you give us an overview of that workflow?
Yes. So let me talk about AI workflow. AI workflow is an orchestration method that integrates data preparation, model training, model inference, model deployment, and automation to help developers and customers perform diverse and complex activities more efficiently. I would like to show you what we have developed using quantization-aware training and inference AI workflow. So we load the model from Hugging Face and we invoke the NNCF Optimum optimizations through Optimum library. And then we get the optimized intake model, and then we validate the performance and use it for ONNX runtime inference because we have it in the ONNX format.
Cool. So I can see how this kind of is all coming together. This diagram is super helpful to see how we're able to leverage all these different open source products to get a good deployment workflow, and then leverage the different hardware and OpenVINO in order to get the performance that we need. So that's really exciting. And we have some cool features on Azure ML that supports these kind of workflows. Do you have a demo that can kind of show us how this would work in Azure ML?
Let me start with the training notebook. As it takes a while to finish it, I'll walk you through the code. In this sample, we are demonstrating quantization-aware training through Optimum Intel. For this demo purpose, we are using BERT model from Hugging Face Hub for question answering use case. Let me start the training notebook as it takes a while to finish it. I will walk you through the code and structure of the notebook and how this particular workflow can be reused for other use cases. This is a quantization-aware training using Azure ML. First, let me start it so that I can go through the code. As you all know, the training takes up lots of resources and time. So I just want to start it. And these are the files that we have been using. So we have a GitHub repo that we have posted the code on. So we're just getting those scripts. And these notebooks are hosted on ONNX Runtime samples repo. And you initialize the workspace. You create a compute and attach the compute to your workspace. And I'm taking the script names that we have, which has the training pipeline, and where we have made those 2 lines of code change. And this is a Docker file. We are taking the OpenVINO base image, Docker image from Docker Hub, and we are installing the Optimum libraries. And based on the Docker file, your environment is being created, which is like a Docker container. And then this is these are the parameters that you provide for the training to happen. Because it's a training pipeline train script, you provide the model name and you provide the sequence length, max train samples, max eval samples. For now, I'm just doing it for 10 samples because I wanted to run it faster for the demo, but you can increase it for better accuracy. You can include whole samples and whole data set of the squad. This is a data set that we are currently using. And this is after you submit the job, after you have configured everything, you submit the job to the Azure ML. And this is the job, and you can click on it to view the logs. And yeah, I think the job has been submitted, and we are waiting for the training to happen. The output model will be generated in your workspace in outputs folder and BERT fine-tune model. It would take about 5 minutes to finish the task. And I have a model that's already generated. So let's go. This is another notebook that I was talking about with Azure ML, where we are using where we are doing inference using ONNX Runtime for BERT model, and we are using OpenVINO execution provider as execution provider. And these are the scripts that we are using: BERT inference Optimum ORT. So similarly, how we integrated OpenVINO into Optimum, ONNX Runtime is also integrated into Optimum library. So if you're using just one library, you can run it through ONNX Runtime with OpenVINO execution provider. So these are the similar things that we have gone through in the quantization-aware training, where you attach a compute and you set the path, and you have environment definition, and you have the same image that I'm taking Docker Hub, which is OpenVINO base image, and I'm installing Optimum on its runtime library. And I'm creating an environment based off of the Docker file, which it will build the Docker, and the container is up and running, and then you can submit the job. So this is the inference script where you can provide the model path and the provider, OpenVINO execution provider, and the input path, the context, because it's a question answering based use case. You provide a context and you provide an input question and you get an answer. Because this notebook is taking a long time, let me go back to the jobs which have been successfully completed so that we can look at the inference output. So this is job that I previously ran. And as you can see, the inference is being run on OpenVINO execution provider. And this is the question, and this is the answer, and the average inference time. So we have seen the eval metrics at the end of the job completion. We have put together the comparison with respect to FP32 model and int8 model accuracy for BERT large. So this is the F1 score. F1 score is among the score that is usually the metric that is used for NLP models. It is known as a harmonic mean of precision and recall, which are based on false positive and false negative. F1 score for FP32 original model is 93.1, and whereas a quantization await training int8 model is 92.83. So from this, you can observe that it's a very minor loss during quantization await training. There's not much accuracy loss, is what I wanted to show.
They're able to keep almost all of the accuracy while getting those optimizations. So that's really powerful.
Let me show the FP32 original model and the int8 optimized model. So as you can see here, these are the quantized linear and dequantized linear ONNX ops that have been added for optimization purpose. These have been visualized through Netron.
Cool. I love how we were able to see the full process, like how we were able to use the quantization we're training, and then how we're able to leverage compute on Azure ML using all the cool tooling that OpenVINO has. Went over a lot, really, now that I'm going back through all of this, and we're using ONNX Runtime to inference and get even more performance. So definitely a lot of information. We'll make all of these links available for everyone so they can go and check out this code and try it out for themselves as well. Let's bring Devang back. Cool. Well, thank you so much for this amazing demo, for showing these really cool features that I'm sure people are really excited to go check out. Is there anything else you'd like to share?
I just want to say thank you to you, Cassie, and just for having us on the show. It was really, really awesome to have to be on here and showcase all these great stuff we've done. Great collaboration and work we've done together on OpenVINO execution provider.
Yes, absolutely. Really cool, forward-thinking things. I love that it's built right into Optimum too. Like Optimum is such a cool thing. So it's like there's all of these really powerful tools coming together just to make developers' lives easier, really, when you think about it. There is a blog post as well. We'll share the link, and definitely check that out. Check out the source and let us know what you think. So thanks so much for hanging out.
Thank you.
Thank you.
Bye. But don't leave us yet. Devang and Akhila are here to answer your questions. Hey, Devang.
Hey, Cassie. Hey, Akhila.
How are you?
Doing great.
Well, yeah, we went through a lot of information there. You know, all like the whole training workflow. We showed, you know, YOLO V8 model or V7. V8's the new one that just came out. So I will share this link below here. So go to this link. This is going to have all of the sample code you saw. It has the blog where it walks you through different pieces as well. So you can go and try this out for yourself. But right now, you should ask us your questions. What are you thinking? Have you thought of ways you want to use this? Is there a use case you're considering that you want to know if it's supported? They are here to answer your questions. So I'll take a peek at the chat. Also, while we're waiting for people to think about questions, you should have seen in the chat that the AI show time is changing. It'll start being on Mondays at 8:30 a.m. Pacific, starting on Monday, February 6th. So people are being quiet in the chat today. I was asking where everyone was from, and no one told me. Where are you two located?
I'm located in San Diego, California.
Nice. Okay.
I'm located in Portland, Oregon.
Portland. Nice.
What about you, Cassie?
On my list of places to go. I'm in Minnesota, and it's
Oh,
cold
nice.
here.
Yeah.
It's nice,
Yeah,
when
it's cold
summer comes
everywhere.
around.
It's cold here too. Yeah.
Yeah. Is it? But what's cold? What's cold for Portland? Is it?
Yeah, that's true. Yeah.
Well, we're not really getting any questions. I'm trying to think if I have any. It was neat to see the question answering model work and see the performance optimization. And it's nice to see that there's not a lot of code. One thing I love about these tools is within Optimum is you don't want to have to change your whole source code to be able to use the tools. And I love these minimal changes with,
Yeah.
yeah. The other thing that's
Yeah.
really
Going
awesome.
forward, it's all
Yeah.
about low code. So yeah.
Oh, sorry. Could you say that again? I missed it.
It's all about low code, right? The new trend. Like
Yeah.
no
Yeah.
code
And
or
like,
low code. Yeah.
and the AI is just going to write all the code for us anyways, right? I use Copilot. It's fun to play around with. But yeah, and like natural language process models and large language models, and that optimization is really important because the models are getting larger, and we need to figure out how to be able to use those to create useful products. So, well, if nobody has any questions, I guess we can let you all go free. Do you have anything else you want to share about this work?
Yeah, just want to share that, just give it a shot, give it a try. I think you'll be able to see the links in the description for this video, but just give it a try. If you are using Intel hardware, right, please use OpenVINO execution provider for ONNX Runtime and check out the workflow that Akhila showed on Azure ML as well, right? And
it can
let
be
us know your thoughts.
repurposed for other models too. Yeah.
Absolutely, exactly. And please let us know your thoughts. Share us your feedback, and we would be we'll be happy to hear your feedback about this. Thank you.
Thank you.
Thank you.
All right. Well, that was awesome. I have not got the chance to play around with that execution provider yet, and I am excited to. But now we are going to get to work. Let's see, I have a cool graphic for this ready. And we are going to be playing with a Raspberry Pi. So one of the projects that I was playing with over the holidays was how to actually get ONNX Runtime working on a Raspberry Pi, which is actually pretty easy, which you'll see. And then thinking about different use cases and things like that. So I did a computer vision model. And actually, let me share my screen too here. So I'm going to have some code and some fun things to demo. So should have had that shared already. Sorry about that. Okay. Perfect. All right. So the project that we are going to be looking at is this one. So I actually wrote it up and it's available in our docs as well. And as you can see here, I also have the project in this video camera here. And let's go over some of the prerequisites first, right? So I'm using a Raspberry Pi 3, which there is newer and more powerful ones, but this is the one I have. And I actually have like a bunch of them. So I really want to buy the next one, but I just can't really seem to justify it because I don't actually really need the extra power. So that's the first thing you need. And if we take a look at what's on this board, we can take a look at the specs here. So we have, gig of RAM, CPU. We have our, I don't know if you can see that pretty well, but we have our GPIO. We are using the ONNX Runtime camera here, which you can, or not ONNX Runtime, Raspberry Pi camera here. And then I have it hooked up to a little HDMI display. This is actually a touch screen. I don't have the touch screen connected. But yeah, so that is our board. And then I've already imaged it. So I've used the Raspberry Pi imager. So if you haven't set up a Raspberry Pi before, they have made it so easy now. They have this imager that you just download and it's in a pretty graphics display. You put your SD card in to your computer using one of these. And then you just image it and you're good to go. And then you just add it in to your board here. So I've already done all of that just because it's kind of a lot of waiting and I don't think you guys want to watch progress bar. Seth, thank you for being impressed with my multi-camera setup here. I love it when I have an excuse to like get out all my toys and use them. So thank you for appreciating that. Okay, so we have our board, we have our image. Oh, here, yeah, this is the imager that Raspberry Pi has if you're not familiar with it, but you just download it and it's this adorable little UI. You choose the OS that you want and there's ones available like just in a little pop-up. You choose your device and then you write. Fahrenheit. You guys making fun of Fahrenheit. I actually, and I don't know how to do the conversion quickly. So what is 0 degrees in? Is it 32? Is that how it is, right? In Celsius? It's cold, whether you're talking about Fahrenheit or Celsius, though. Okay, so we have this. Oh, the other thing that I realized when I was playing around with this is because this is actually a touchscreen and this supports touchscreen. If I had a DSI cable to connect the two, I could actually interact with it on the touchscreen there, which would be pretty cool. But I was searching through all of my IoT stuff, which is all over the place. I really need a good organization system for them, but I didn't seem to find that one anywhere. So I'm pretty sure I don't have it. But I mainly just use the that display when I'm like setting it up and I don't want to use something else. So we're going to be using the VNC viewer. So this is a nice little app that allows you to connect to your device. So that's what I have here. Why don't we wake it up and get connected? And so now you'll actually see that it woke up here. I don't know if you can see that in the screen there, but I can actually interact with it right here on my computer. So that's nice. I think there's some cool tooling in VS Code to do that as well, but I've never tried it out. There is some configuration to do in order to get VNC viewer to work. I've already done that, and this is also linked in the blog, but you want to install, and then you want to do a config and make sure that you have it set up for your Raspberry Pi. So all of that stuff is right in this blog. And actually, let me send this link over. Well, it's a tutorial on our ONNX Runtime docs. And then once you have it all set up and imaged, then you can boot your device and we can look at the code. So the source code, let me close some of these here. I have on my GitHub, I'll share this in the chat as well. So all the code to run this on the Raspberry Pi device is available right here, and we're going to walk through it. One thing to think about is, the size of the model and how much computing power you need. So not all models are going to work, but I think there's some just really cool kind of like edge, solutions that you might need. Like I think in manufacturing is a neat idea of just having computer vision that does some sort of quality check, or honestly, there's probably even more than there's tons. So I've been thinking about using one to create my own voice assistant, and I haven't done that project yet, but that's probably going to be the next IoT thing I build. But yeah, so you got to make sure that your model is small enough and that it can actually process and run the model and has enough memory and all that stuff. So we're using a model that is optimized specifically for this from the ONNX Model Zoo. So if you're not familiar with the ONNX Model Zoo, it is here. Let me share this link in the chat as well. Oh my gosh, Seth in the chat said I can use, I got to show this one. That's pretty great. So CNV is his custom neural voice. So that means that I can make a little virtual Seth to be my assistant. And of course, ethically, he's given me, you all saw, he gave me consent to use his voice on my virtual assistant. I feel like it would need to have like some dad jokes built in, Seth. So like if you could send me kind of a collection of those, or maybe I can just integrate with like ChatGPT and do a cloud call and be like, hey, give me a give me a dad joke that Seth Warres would say. This might be a good product. This is good. Oh my gosh. Okay. So, and that's actually really neat though to think about. Like you could create your own custom neural voice, which is a service in Azure, and then you could create your own chat assistant. And I don't know about you, but I use my chat assistant, I feel like, for like 5 main things. And so when I was thinking about building my own, I'm like, I don't use all kind of like the bells and whistles of Alexa. I use a lot of home automation stuff and like shopping list, timers, and like that. And so it would actually be pretty neat to see if I could build one that would replace everything. Okay, so the ONNX model zoo, we have all kinds of different models here, and we are using a MobileNet model because they are small. They have pretty good accuracy, which means they can run on my device without issue. I was actually playing around, and I can show you after we do this one if you want, with the YOLO V8 model. So this is like, we saw YOLO V7 in the demo before. YOLO V8 just came out. And I found this repo, I forked it, that has an ONNX and ONNX Runtime implementation. And I was playing around with it, and my Raspberry Pi can just like barely do it, which maybe that's my excuse to get the 4. Like maybe the 4 with some better specs could actually run this better. But it does run, but not very performantly on the Raspberry 3, just because of how large it is. So where was I back? Oh, models. That's right. Okay. So yeah, we are going to be using the MobileNet model, and I have already cloned this repo, so we'll go in it. But if you were starting new, you would want to go ahead and you can clone it directly to your Raspberry Pi from the GitHub, and it'll have everything for you. It has the model and the source and everything, so you would be good to go. So here is the source code. If you can't see that, let me know. Seth is asking, have I tried the NVIDIA Jetson? It has a baby. I really want to try that because I bet it would work really well for that YOLO model, YOLO V8 model. So yeah, this one doesn't have a GPU, but I don't have a Jetson board. I have Orange Pis, I have Raspberry Pis, I have the cutest Raspberry Pi, which is the 0. And yeah, but I don't have a Jetson. I should try it on that, which is also supported. We have, let me go back to here quick, because we actually have a tutorial on how to use Jetson Nano as well. And I think that's the one that you're talking about, right? Is that the same device? Let's see, what are the specs on this one? Well, that one says it's ARM. Oh, so you're saying it's the NVIDIA Jetson. I think that's a different one than this, but it would work, I'm sure. Let's look up that device. So it's the NVIDIA Jetson. Maybe it is the same one. Let's see. Jetson modules. Oh, there's a bunch. Has anyone else tried these out? Have they done any IoT AI stuff and seeing what they can get done with these different devices? I want to see. Show me the specs. Click to expand. Seth has one and it's collecting dust. Well, you're really far away, so I was going to say I'll come borrow it, but that would be you're all the way on the coast. But yeah, I should just get one and play with it because I think there's some really neat AI use cases for edge devices, and it's also neat because when you can run it right on device, you don't have you reduce latency. There's a lot of advantages to running on device. So that's cool. I should look into those. So Seth, you can use your Jetson Nano and create yourself as your own assistant. And maybe it can even give you some ideas for your dad jokes. Could use it as a like what's it called? Not an assistant. I guess an assistant, but all right, let's go back to our code. So the code for the mobile net, it's, you know, like if you've done computer vision, this isn't anything that different. You know, you have to preprocess it, resize it, you know, all of those same things that happen with any computer vision model. And I think I even grabbed some of this from some existing sample code. So that's the other thing is like if you go in to use some of these open source models from the Model Zoo, or maybe you're using Hugging Face, they usually all come with like the inference code and everything you need. So there's really not a ton of like, if you haven't done computer vision, I mean, feel free to ask, but I feel like most people are pretty like familiar with the pre-processing that needs to happen. We're using ONNX Runtime here, and then we're grabbing our model, creating our session. We're capturing an image and then writing it out. So we'll be able to see the image that was used. So when we run this, it's just going to print out the predicted classes, the top 5, and then it's going to show the image that it used. So the other thing that I added to this was a camera test, because like the first thing before I started running the inference to see if it was working, I wanted to make sure my camera was working correctly, right? Because I actually hadn't used this. I had got it, but I never actually used this camera before. So to do that, we use OpenCV in Python. I do a video capture, and then I also open a live video feed that you can hit escape to quit. So let's go to our code here. So again, I already, that too small? That looks pretty small for you guys. Can I make this bigger? There we go. Now you can see it. Okay, so this is my VNC into my Raspberry Pi. And I've already downloaded this source onto my device. And so then to run the camera test, let's do the camera test first. We are just going to go ahead and hit run camera test, and then we should see a actual live video feed show up here in a minute. There it is. There I am. Hello. Oh, that's not a good angle. Down angle's never good. All right, so our camera is working. We'll escape out of that. And then we can also go to the thing here, and then we can look at our test snap that we did. There it is. So there is the test. Cool. So let's go back to our code here. And you can see here's our model. We have our model V2. We have our inference classes so that we're able to map that back to the top labels. And then we'll show the capture again. So this will update with whatever the images that it uses to inference. So let's actually put like my little Raspberry Pi Zero. Let's put this in front of it and see. Although I doubt that's on it. Here, let's do a pen. I feel like a pen is a common item that it would have. So let me try to set this up a little bit, and then we can run the inference on it. There we go. Maybe that's big enough. Maybe I should put it like back a little further. Let's try it over here. Okay. And then we are going to do Python inference mobile net.py. And then we should see the output of the different classes. I feel like this doesn't kind of gets lost. Right, there it is. Has hourglass, bow tie, spotlight. Okay, let's see what it actually took a picture of. I might not have put this in a good. I wonder if this this pen is kind of an interesting pen. Well, let's see. Okay, here's the capture. Yeah, there's a lot of noise in that image. Let's try. I think I have like, ooh, we could use a Microsoft pen that looks more like a normal pen. And then let's try to reduce some of that noise. Let's see. Maybe if I just hold up, I have a blanket. I'm gonna hold up. Okay, let's try again. I'm gonna hold up the blanket while we inference and see if reducing some of that noise gives us a better result. Now this model's pretty small though too, so it's not gonna be the most accurate one. I think the way to go would be getting one of those nicer GPU devices. Let's see if this helps at all. So it's pretty quick. Fountain pen, it got it. Ballpoint pen. Okay, so it was the noise in that other image that was probably causing some model confusion. And if we take a look at our capture, yeah, so that one's much clearer. And there we go. So that's all happening on device, which is pretty cool to think about, like the fact that you don't have to call out to web service. So like if you were at a facility or something where you didn't have internet connectivity all the time, or you wanted to do inference and only send messages when a certain thing happens. Like there's so many different ways that you could use something like that. And then also you could train a model to work for your, here, let me make that bigger so you can see the results better. There we go. Yeah, so you could train a model specific to whatever you need and then do things like maybe the quantization aware training, which we saw a little bit in the other demo, or quantize the model after training. The thing about doing quantization aware training is you can keep a lot more accuracy than if you do quantization after you train the model. There is some cool quantization tools within ONNX Runtime though. If you have not, let me think I have a demo, or let me just see if it's in the docs first. I mean, it is in the docs. Some of the examples here that will show you how you can quantize. It's actually like 3 lines of code. So when you want to quantize an ONNX model, let me zoom this a little bit. You import the quantization, and then you literally send the model in and then the size. So there's another, let me see what's in this example. Let's take a look. We have a lot of examples in our ONNX Runtime inference examples. And let's see here. I thought they had a good one. I know I have one, but I have so many different projects, I'll probably never find it. Like, I don't know about you all, but if you play with a lot of different projects, I end up getting so many, I have to like re-image my computer just to like get a nice reset because of all the different things that I play around with. But anyways, it's like 3 lines of code. I'm going to work on a tutorial for this, so there should be some new stuff for this soon. Oh, here's a notebook. Let's take a look what that is. So this is the BERT glue. If you put that together. Okay. And wait, what are we doing here? We're getting some models. We're installing our packages. And then we are running our script. We are using the transformers package. So here's another example of, this looks like this is torch quantization. So PyTorch has quantization tools as well. Let's see. Well, I will provide an example later. Oh, here, is this it? ONNX Runtime quantization. Here we go. This is what I was looking for. So you have your model, and then you're just giving it the type. So we're quantizing to int 8. So it really is a small amount of code, and you can reduce the size of your model a lot. And then you'll want to check the accuracy differences. You will lose a little bit of accuracy. But like I said, if you do quantization aware training, you'll lose less when you actually do the quantization with different tools. which you saw when with the tool from OpenVINO as well. And that's all built into the Optimum library. So there's lots of different ways that you can do that and lots of different things to experiment with when you're trying to get something to work on an edge device, get something optimized to that level. Anybody have any questions yet? People have been so quiet today. Questions about edge IoT or different quantization, optimizations, model questions, scenario questions? Okay, so let me go back to where did I? There we go. So I think, like, I didn't go into detail in the code. I guess I could. I see yes. I don't see what the question was. I just see someone commented yes. But yeah, so you can see once you actually figure it out. The other thing that's cool about the ONNX Runtime package, oh, I should show this for when you are deploying. If you take a look, there's all these, you know, pre-built wheels to support different things. So like we have an ARM device, so that's already available. So like most of the time you don't have to like build, you know, ONNX Runtime or anything like that for your particular architecture. There should be a wheel that when you can just pip install and it'll do the right one. It'll access the right one based on your hardware. So that's nice. Here's actually another OpenVINO one. Did we look at, I don't think we looked at this tutorial. This is a different tutorial. This isn't the one from earlier. I don't know if I've played around with this one. But here's another, this one's using the Azure IoT Edge. So Azure has a lot of different like IoT tooling to kind of bring everything together in a centralized place for your different devices where you can like register your device. And then there's this like home. I've used it before. It's really cool. I could do a whole AI show on that. But yeah, so that looks like what this one is. If you're interested in getting, when you have more of like an enterprise solution or you have a lot of IoT devices that you want to manage, it's really helpful. All right, well then with the little bit of time we have left, why don't we, okay, if you want to see my Raspberry Pi, it totally get frozen. It does kind of work, but I can show you the YOLO V8 I was playing with this morning that I was wondering if it would work. Let's see. So with the YOLO V8, let me show a little bit of this code quick. And it's an object detection model. If you don't know what the YOLO models are, you can close this. So these are the different sizes of the MobileNet models. Can close that out. So I, like I said, I just forked it from this library here. I don't know how you say his name, but so he recently took the YOLO model V8, converted it to ONNX, and then put some source code up for actually doing the inferencing with it. And so I bet the Jetson, the NVIDIA Jetson, I bet it could run the ONNX Runtime or the ONNX model, this YOLO V8. It could probably run it without a problem because mine can run it. It's just you probably wouldn't because it's a little slow. So this has a couple different options in it. So it has a webcam object detection where it's actually going to take an image with my little camera over here. And then it also has one where it just grabs an image from a URL and does object detection on it. And then obviously it has like your requirements that you can install. So you have your packages, as did the Raspberry Pi one that I showed you, that source. When you download it, you can just pip install your requirements and then it will run. So let's try this. So let's do the webcam one. I think we can just like leave the pen there. Actually, I'm going to leave the noise too. I'm not going to like put the blanket up this time. And let's see if this crashes or if it will work. The joy of live. You never know. And this one takes a little bit longer. Like I said, it's a larger model. It takes more processing. It does more things. So it takes a little bit longer to run. it checks if a GPU is available, and then it does the inference. So it's happening. Takes it a minute to render it, though. But yeah, now I really want to try this on a GPU-enabled device because I bet it would be awesome. So this is what happened earlier. And then, oh, there it went. It worked. Where's my segmentation, though? Did it not find anything? Okay, let's try it again. But let's try it with like something that it might be able to be better. That's still kind of not a great. Oh no. There, okay, no, hey, it worked. That worked even better than earlier. Okay, let me try to find something on my desk. My desk is a disaster, but like, what about like an iPhone? Should I use my iPhone? That might work. Let's see if, I'm gonna move this back a little bit. And then, actually, you know what I'm gonna do first? Let's get it set up by using my camera test from my other project. Okay, I don't need to keep doing that, don't I? That's right here. Okay. So this will open up my camera, and then maybe I can see like what would be a good distance to try to do some segmentation. It's still pretty big. Okay, let's see. I need something smaller, I think, even. How about like this plug? I have all these things. That might work. Oh, let's do that. Let's see if it'll do that. I don't know what classes. That's the other thing is I actually don't know all the classes that it supports. So it's possible that I'm trying to classify things that it doesn't have classes for. Actually, let's look at that quick. Let's look at what YOLO V8 supports. Okay. My mouse is, there we go. Is there not a labels file here? Let's look at the models. All right, let's go to the internet. Take a look and see what classes we're working with. Has anyone else played with the YOLO V8 model? I'm actually really impressed that it worked on my Raspberry Pi because earlier today I was having some issues. Well, I don't know where the classes are. Let's see, introduces new features and improvements. Range of object detection, image segmentation. Yes, I know this. So it looks like they've improved speed and accuracy, so that's cool. All right, well, let's try it again because it takes a minute to run anyways. And then when it thinks about the inferencing, because it does take a minute. It's working. Did I? Oh, I did CS, which I do all the time. Oh, and then I want Python webcam. There it is. Okay, see if I can segment the plug here. And then while it does that, let's see if I can find what classes it actually supports. Although I feel like it still should detect the object, regardless if it knows what it is. So it's kind of working, but it's not actually drawing the segmentation. So like if you saw from the example, what it should look like, right? We should see, oh, that's all person. Is it only looking for people? Should I try to get in the, should I try to get in the inference? Oh, there it does bicycle too, truck. I wonder if it's more, if it's just that it's not recognizing any of the objects that it's been trained on. I bet it's probably. Oh, here, this is a cool demo of how it works. Okay, I'm going to do one more test with it. And I'm going to point the camera at me and see if it will work on that. And then if not, then I'm not sure. But earlier it was getting it to inference at all was difficult. So let's cancel out of this. All right. I'm going to let's make this bigger so we can see what's happening. And no, it takes a minute. All right, let's see if it can, if it will find me in this camera. Suspense. All right, so it should have already taken the image. So I think I can set it down. Well, let's see. Oh, it segmented me. Look at that. It worked. So it looks like in order to find the object in the image, it needs to know what the object is. So that's cool. I didn't know that. Cool. Well, we got it to work. We got YOLO V8 to work with ONNX Runtime on a Raspberry Pi. And with that, I think I will say goodbye. Thank you for hanging out with us today. We got to go over a lot of cool things today. We got to play with Raspberry Pi. If you make any Raspberry Pi projects with ONNX Runtime or any AI models, let me know. I'd love to see them. And yeah, thanks so much. See you next time.